Another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR NET and GATE exam. So we will be, just a second, we will be talking about so many important topics, concepts, and the points in this session today. I hope everything will be helping you a lot to take your preparation to the next level. But in case if there will be any question, query, or doubt you will have at any point of time, you can surely let me know about it. Let me just see whether everything is working okay or not. Mm-hmm. And then I'm gonna start the discussion too. Okay, I think everything is all right and clear. Okay, let's go ahead then. So actually guys, if you are gonna be the one who wants to do the best preparation under the guidance of top educators, then you can take the Unacademy Iconic or Unacademy Plus subscription, or even Unacademy Lite subscription is there. I'll be sharing all the details about these important subscriptions right now. Even now, the notes are available on the learning app, which will be helping you to take your preparation to the next level. So what are the benefits you will get if you will take the Iconic subscription? All that has been shown here on the screen. And you can use and apply the referral code, that is Anjali Live, whenever you will go ahead to take the subscription, because it will be helping you a lot to get the discount in the total subscription amount. And along with that, after taking the subscription, you will be able to get so many benefits as shown here on the screen. And this slide is regarding the plus subscription. So what are the benefits you will get if you will take the plus subscription? All that has even been shown here on the screen. You can use and apply the code, that is Anjali Live, to get the discount in the total Unacademy subscription amount. Even so many courses are going on Unacademy, and many new courses will be starting on Unacademy, which will be helping you a lot to take your preparation to the next level. Other than this guys, this is about the Lite subscription, and here you can easily have a look at the difference between the Unacademy Plus Iconic and the Lite subscription. So it will even help you to know that which one will be helping you more, whether Plus Iconic or the Lite subscription, and which one will help you to take your preparation to the next level. So this is how guys, everything is going to be very much important and will be helping you a lot to take your preparation to the next level. Let's go ahead and let's even have a look at few more slides, and then I'm going to start the discussion about the important questions and concepts. This is regarding the Unacademy Learning app. This is something about the session. This is something about me, and this is about the community feature. So with the help of community feature, which is there on the Unacademy Learning app, you will be able to get to know about the latest updates, the important information you will be able to get there about the new courses, and any new or latest update you will be able to get on the like community feature on Unacademy Learning app. So this is how it will be helping you a lot, and you can stay updated with this. So if you are the one who thinks like you want to get the guidance by the top educators, or even if any of your friends want to take the subscription, you can share this information with them and let them know about the different subscription, and whichever they think or you think can work better for you, you can take that subscription and start your preparation under the guidance of top educators today. So here we are having all the details, and now we can start the discussion about the important questions we will be considering today in this session. If in case you will have any doubt anywhere, you can tell me about that. Let's start the discussion with a quite simple and easy question, and let's see how many of you know the answer for it. But if you don't know, I will be helping you then. So it is, consider X-ray diffraction. From a crystal with a face-centered cubic that is FCC lattice. The lattice plane for which there is no diffraction peak is options are 2, 1 and 2. The next one is 1, 1, 1. The next one is 2, 0, 0. The next one is 2, 3, 1, 1. So guys, in this case, what they're asking you to find, if you know the answer, just mention it in the comments. I will try to consider it. And if you don't know and you are not having any answer to give for this question, I'm gonna help you in that case. Consider X-ray diffraction from a crystal with a FCC centered cubic, or that is face centered cubic. I just read it in short and then read the further terms too. Okay, face centered cubic lattice. The lattice plane for which there is no diffraction peak. So here you need to know about the some selection rules. Like if I'm going to talk about simple cubic lattice, so for all HKL values which represent the Miller indices, you will be having the reflection possible. Okay, so you can observe the Bragg reflection for that, or X-ray diffraction in that phenomena. For BCC, it will be for any combination for which H plus K plus L is what? Even. Okay, you can easily get the diffraction peak. But for FCC, either the HKL must be all even or all must be odd, then only you can observe the diffraction peak. So if you will see the A part, it's going to be 2, 1, 2, which is even odd combination. Hence, in this case, for FCC, you will not be able to observe any diffraction peak, right? So that means your option A will be the correct answer, because they have asked the lattice plane for which there is no diffraction peak is. So that's your option A, and that is your correct answer you will have. Let me know if in case there is anybody having any doubt, we can talk about it then. But if everything is getting clear, then we can take the next question too. Okay, so does it make sense? And are you gonna get it like, oh yeah, that should be the correct answer we will have? Excuse me. If yes, I'm gonna have the next question for you, which is quite interesting. Most of the students select the wrong answer for that question. Reason you will understand soon once I'm gonna give you that question, and you will observe like, oh, this mistake is most common. Yeah, even after knowing everything, there are chances for making that mistake. Now, what is that? Let's have a look at the question first. Let's observe it. What do you think about that part? Okay, so here it is. A metal with body-centered cubic with body centered cubic, which is simply BCC structure, show the first that is smallest angle. Diffraction peak at a Bragg angle at a Bragg angle of theta is equal to 30 degrees, the wavelength of X-ray used is 2.1 angstrom. The volume of the primitive unit cell of the metal is. Of the metal is. Try solving it now and let me know that what do you think will be the right answer for this question. If you're not gonna get it, I'll be helping you in that case. It's angstrom cube. The another one is 13.1 angstrom cube. The option C is 9.3 angstrom cube. And the option D is 4.6 angstrom cube. Let me know if in case there is anybody having any doubt in relating concepts, you are having difficulty or any way, you can just let me know and we will try to consider it. So what is given in this question? You can even try working on it. If you are getting the answer, let me know what is the right answer according to you. And if you are not getting it, you can tell me. I'm gonna start the discussion as well. So the question has given you a metal with a body-centered cubic BCC structure. Show the first, that is the smallest angle, okay, diffraction peak at a Bragg angle of theta is equal to 30 degrees. The wavelength of X-ray used is 2.1 angstrom. The volume of the primitive unit cell of the metal is what? That's what they are asking you to find, right? So when you have read the question and you got this word Bragg angle written there, you can easily consider, oh, it is related to Bragg's law. So what is the important expression as per the Bragg's law? It is 2d sine theta is equal to n lambda. Okay. Now what will happen in this case? They are talking about the first diffraction peak, right? So that means what is the value of n? It's 1. And did they give you the wavelength? Let's have a look at this. Yup, it is 2.1 angstrom. So lambda is 2.1 angstrom. What about theta? It's 30 degrees. So what about the question? They're asking for you to find the volume, right? And if you will get the D, because for the first diffraction peak of BCC case, what will be the HKL values you have to take? It must be 110 or 010 or 001. What is the reason behind it? Generally, we will go over 110, but all of them will give you the same answer. Why we are not taking 100? Because for BCC case, you can only observe the diffraction peak if the H plus K plus L, the sum of these ones, if it is even value. So for 110, you can easily get the even value, and that's how you will be taking the HKL to be 111. And what is D? D is the interplanar spacing. For the BCC case, it will be the lattice constant divided by the square root H square plus K square plus L square, right? So in this case, what will happen? You are going to have 1 plus 1 plus 0, which is the square root 2. So 2a over root 2 you will get here, sine 30 degrees, and that is equal to the 2.1 angstrom. When you simplify it, can you get the value of a? I think everybody can get it. You can just work on finding the value of a and tell me in comments that what is that value you are going to get here. But if you're not gonna get any value, I'll be letting you know what final value you should have, and you can check out the calculation you are gonna do. Okay, so that is 2 point, I think you are gonna get it as A is equal to 2.97 angstrom. Just check it out and tell me that are you all getting it or no. If yes, that's great. If no, you can just tell me that. So 2.97 angstrom will be your A value, right? If we are going to talk about the volume, you can even check it out. If still you are having difficulty in getting it, let me know about this part. I will explain this to you, that how you will be able to find this value. Other than that, if we are going to talk about the volume of primitive unit cell, so what it will be your A cube over 2. Reason behind it, in case of BCC structure, you know that your effective number of atoms will be equal to 2, right? So you want to find the primitive unit cell volume. So A cube is the volume of all the atoms we will have there, complete cell. Okay, so in that case, primitive one means for the effective number of atoms to be 1 there, what will be your value? So it is A cube over 2 will be the volume for the primitive unit cell. Just plug in this A value here and you will be able to get your answer. If somebody will just find A cube, they will get 26.2. But after dividing it by 2, you will be able to get the 13.1. So that was the point why most of the students make mistake even after reaching to the final step, because they don't consider dividing by 2 part, and that is the reason they get the wrong answer. Okay, so for the primitive unit cell, you have to divide by 2, and that gives you 13.1 as your final answer. You can tell me if in case there is anybody having any doubt. We can talk about that part and we can consider it, that what doubt or difficulty you are going to have. We can talk about it. If everything is clear, let's go over the next question now. And that is something important as well. It is related to this part, guys. The dispersion relation for a one-dimensional monoatomic crystal with lattice spacing A, which interacts which interacts give me a second, guys. Done. Which interacts nearest with nearest neighbor, and harmonic potential is given, which interacts, whether in the statement we don't have anything else, so I'll be writing it in the same way too. Okay, with which interacts with nearest neighbor harmonic potential is given by omega is equal to A mod sine k over 2. Where A is a constant of appropriate unit. Okay, and now the question is, the group velocity at the boundary of the first Brillouin zone is. Options are 0, 1. Next one is root a square over 2. And the next one is 1 over 2. This one. Let's consider it. If you're gonna get the answer, you can just mention it in the comments. What is the right option according to you? If you're not gonna get it, I'll be helping you in that case. So they have given you the dispersion relation for a one-dimensional monoatomic crystal with lattice spacing A, which interacts with nearest neighbor harmonic potential, is given by omega is equal to A sine k over 2. So in this case, omega versus k relation is given to you, which is a dispersion relation, right? So in that case, what will happen? You have to consider the group velocity at the boundary of the first Brillouin zone is what? Now, what is the meaning of group velocity here? That is simply d omega over dk. So when you are having this, and one more condition they have applied, that at the boundary of first Brillouin zone, which means that k is equal to plus minus pi by a. Instead of taking plus and minus both sign, you can just take plus pi by a to make it simple and easy for you. Okay, now when you go over this part, what it will give you? It will give you a by 2 capital A cos k over 2. And when you will plug in the value of k, that is pi by a, so it was ka over 2, right? It will just give you the k pi by a you will plug in. So pi by a over 2. So a cancelled out, cos pi by 2 you are getting, which is 0. Hence your right answer is option A. This is how you can get it, because cos pi by 2 is 0, right? And now one more question they have considered in this same question, second part. What is that? Let me just quickly tell you. So in that part they have mentioned the force constant between the nearest neighbor of the lattice where m is the mass of the atom options are m a square over 4, MA square over 2. Next one is MA square. And the next one is 2MA square. Let me know if in case there is anybody having any doubt in any of these parts, we can consider it then. And if everything is clear, that's great, great, great. So actually guys, in this case, what will happen? In this case, they have given you the force constant between the nearest neighbor of the lattice is what? Okay. Now, in this case, they have also given you the situation here that it was one-dimensional monoatomic crystal with lattice spacing A. So, if you have studied this topic, you will be familiar with its standard expression. In the standard expression, you will have here square root for beta over m. Means it is something related to this. For beta over m, where beta will be your force constant, sine Ka over 2, right? So when you compare this, you just need to compare your first part A with this, root 4 beta over m, and from there you can get your beta value. So A is equal to square root 4 beta over m, and beta will be equal to ma square over 4, and that's your option A, which is the correct one. So for this second part, you need the information, or you need to have the idea about the standard expression, the main expression, so that you can answer this question. But in case if you're the one who is having difficulty in recalling it, or you think you didn't prepare that standard expression, then after solving this question you can focus on that part as well, so that you will not have difficulty in your upcoming questions, and you will easily be able to work on those parts too. Okay, let me know if in case there is anybody having any doubt, we can talk about it then. And if everything is getting clear, then that's great, great, great. We can take the next question. If you have any question, query, or doubt, guys, let me know. We can talk about it. I'm gonna give you the next question now. A lattice has the following primitive vector. Which is in angstrom. Such that vector A is equal to 2 times the j plus k cap. And vector B is equal to 2 times k cap plus I cap. And vector C is equal to the 2 times I cap plus j cap. Okay. The reciprocal lattice corresponding to the above lattice is if you are familiar with the standard forms of the simple cubic, BCC, FCC, for these cases, you will be able to get the idea about it, like what kind of lattice it is. Is it BCC? Is it FCC? Is it simple cubic? The values of vector A, vector B, and vector C, which have been given here. So if you're gonna get that, that's great. But if no, you need to prepare that too, because it's important, right? Because if you will be familiar with the standard form, it will help you to identify what kind of lattice they are talking about, and then simply you can just get its reciprocal lattice too. For example, for simple cubic, its reciprocal lattice is simple cubic. For BCC, it is FCC. For FCC, it is BCC you get, right? So it makes it easy to answer such type of questions then. I'll be even helping you to answer this, but after completing the question and after giving you the time to work on it. Oh, it changed on its own. Let me just go back to that slide. It's here, guys. So it's gonna be BCC lattice with cube edge of pi by 2 angstrom inverse. Your option B is BCC lattice with cube edge of 2 pi angstrom inverse. Option C is FCC lattice with cube edge of pi by 2 angstrom inverse. Now why that inverse is going on everywhere? Because it's the reciprocal lattice we are talking about. So for the direct lattice, you take the unit of length, which is like angstrom only, but for the reciprocal, you take the inverse in the unit. Okay guys, these are options and this is question, and let me know if you are gonna get it done and whatever is the right answer according to you. But if you can't get it done, I'll be helping you in that case. I will let you know what you have to consider and what steps you need to take. So actually, a lattice has the following primitive vector, that is in angstrom, like vector A is equal to this, but they didn't mention whether it is FCC, BCC or simple cubic. So we have to identify it. It's basically going to be your FCC case, okay? Because you know, for face centered, you are just connected to two axes, not the all three, okay? So in that case, you can see you are having two directions given in the particular expression. So it is what? It is FCC. Okay, that's the way you can consider it. Now for the vector A, vector B, vector C, which are given to you, it's FCC. So its reciprocal lattice will be BCC. That means it can be either option A or B, which will be correct one, right? So in that case, now you need to know about the formula to find the reciprocal lattice vectors. So let's say I'm calling it capital A, and then it will be B cross C from the direct lattice divided by like 2 pi times this. First of all, you can take that, and A dot B cross C. Your denominator will remain same in all the A, B, C expressions. So vector B will be 2 pi C cross A, and it will be A dot B cross C. You will have to consider. And our vector C is equal to what? That will be 2 pi. It's going to be A cross B over A dot B cross C. Now how it's happening, what you are doing in this case? Actually, when you are writing the formula for A, you are taking the further terms like B and C there. For B, then you are writing C and A there. For C, then you are writing the next one, A and B there. So it's the easiest way to memorize it while your denominator parts are remaining same in all these cases. So this is how it will be helping you. Okay. Now you just have to plug in the values of vector B and vector C there to get the capital A, and same way for C and A will plug in the values there to get the B, and then for C, like this is how everything is gonna be easy for you to consider. And you already got to know it is FCC. So once you will simplify it, you will get here, I think you are gonna get this, but if you are getting something different, you can even mention it in the comments. So what you will get is capital A is equal to, after plugging in the values in the formula I have told you here, okay, I think you are gonna get pi by 2, then one sign negative and the other two positive. It will be having I, J and K all terms, but the sign you can see what you are getting there. Same way for B, you will have the pi by 2 times all the terms I, J, K, but you can have different sign present there. Same way for C vector, you will have the same, okay, and I, J, K terms you will have there. So what will happen in this case? This is representing the BCC, okay, and as you know, there we didn't take the sign, so whatever sign after simplifying you are getting, just consider them, and this is going to give you the reciprocal lattice vector, which is BCC, and because it was for FCC, it's gonna be BCC. So pi by 2 is going to be the side or the edge, so that's how your option A will be the correct answer, okay. So after simplification, how you are gonna get it, you can easily get that idea from this section and the part we have worked on. If still there is anybody having any doubt, just mention it and let me know about it. I'll be talking about that then, okay. And if everything is getting clear, we are ready to take the next question. You can let me know if you are gonna have any question or query till now. Otherwise, next question is waiting for you and it's here. So the question is, the dispersion relation give me a second guys, I am gonna have a look at this. The dispersion relation for phonons is a one-dimensional monoatomic Bravais lattice with lattice spacing A, lattice with lattice spacing A, and consisting of ions of masses and whatever questions we are considering here, the concepts based on it, which we are taking the questions we have taken in this session or even in the previous session guys, everything is important. Before this, I already had a session on nuclear and elementary particle physics, so even if there was someone like who didn't attend it and you want to check it out, you can check the recordings of that session, it will be available to you. And every concept we have taken there along with the question, it's quite important, so you can learn many concepts with that too, and with this session as well. 1 minus cos Ka, it's here, I need to change this bracket, okay, where omega is the frequency of oscillation, K is the wave vector and C is the spring constant. K is the wave vector and C is the spring constant. For the long wavelength modes, lambda is very much greater than A. Next thing is the ratio of the phase velocity to the group velocity is what? That's what you need to find. Options, actually we don't have options for this, but still I'm just gonna give you some options. Okay, try working on it and let me know if you're gonna get the answer. But if you will not get it, I will be talking about that. I'm gonna even start the discussion for solving this type of question, that what you have to do, how you have to proceed further, what steps you need to take, and how you can get the answer. So everything I'll be talking about, but I want to give you some time so that you can even try working on it and you can get to know whether you can get the answer for any such type of question or no. Let me know, let me know, let me know if you are gonna have any doubt. Okay, let me just even start the discussion, guys. So actually, in this case, what's going to happen? The dispersion relation for phonons in a one-dimensional monoatomic Bravais lattice with the lattice spacing A and consisting of ions of masses m, that is given as this. So we also call it the dispersion relation because it is omega versus k relation. And it is associated with the 1D monoatomic lattice. That's what we got to know with the above statement. Omega is representing the frequency here, frequency of oscillation, k is the wave vector, and c is the spring constant. For the long wavelength modes, that is lambda is very much greater than a, and you know k is equal to 2 pi over lambda, where k is the wave vector. So if lambda is large, then k will be small, right? And once you got to know about it, what will happen? When k is small, so for a smaller value of theta, cos theta can be written as 1 minus theta square over 2. So that means you can replace this cos Ka with the 1 minus Ka square over 2. And once you're going to do that, it will be giving you 1 minus Ka square over 2. Negative sign is outside the bracket as well. So it will give you this sign. 1 and 1 will get cancelled out. You will just get Ka square over 2 from there. This 2 and 2 will get cancelled out. So you will get Ka square root C by m as omega. If anybody is having any doubt or you are not gonna get it, you can surely let me know about that part. Wherever you are having confusion, I'll be talking about that. Now, after applying the condition for the long wavelength, we have got this, but we need to find the phase velocity to the group velocity ratio. Now, what is this phase velocity? It is simply omega over k. And what is the group velocity? That is d omega over dk, right? So what will happen in this case? When you will divide this omega by k, you will get a root c over m. And when you will differentiate it with respect to k, you will get a root c over m, which means your Vp and Vg are equal, and that will give you the answer as 1. Hence, your option B is the correct answer here. If still anybody is having any doubt or something you are not gonna get, You can tell me about that. But if everything is clear, that's great. We can go over the next question then. I'm gonna write the next question on the other slide. But still, guys, if you're gonna find like something is not clear to you or somewhere there is doubt, you can just simply mention it and I will be talking about it too. Oh, there is nothing written on that slide. It's here. Okay, let's take the next one. The energy versus wave vector versus wave vector that is EK relation. Relationship near the bottom of a band, near the bottom of a band for a solid can be approximated as E is equal to A K square plus B K A to the power 4, where the lattice constant A is equal to 2.1 angstrom. The values of A and B are 6.3 times 10 to the power negative 19 joules and 3.2 times 10 to the power negative 20 joules respectively. At the bottom of the conduction band, the ratio of the effective mass of the electron to the mass of free electron is. Options are 0.14, option B is 0.22, option C is 0.36, option D is 0.44. This is what you have to consider. Now work on it and let me know what do you think is the right answer, and you can start working on it. If you're not gonna get the answer, I will be helping you in that case, guys, but I'm gonna wait for your reply for just few seconds too. And even after that, if you will get the answer, you can mention it in the comments that this is going to be your right answer. Let's consider it. The energy versus wave vector, that is EK relation. We also call it sometimes the dispersion relation. Like you can find different names for different relations too. Okay, near the bottom of a band for a solid can be approximated as E is equal to A Ka square plus B Ka to the power 4, where the lattice constant A is equal to 2.1 angstrom. The values of A and B are 6.3 times 10 to the power negative 19 joules. Okay, A and B values, capital A and capital B values are even given to you. A value is even given to you at the bottom of the conduction band. Great, great, great. Okay, exactly at the bottom of the conduction band means the K must be equal to 0 because it is exactly at the bottom, right? It's not near the bottom, it is at the bottom. So at the bottom of the conduction band, the ratio of the effective mass of the electron to the mass of free electron is, right? So what is the effective mass? That's going to be the h² over d2e over dk square, right? In that case, what will happen? In this case, if you will differentiate it with respect to k twice, what you will be getting? So you may be thinking that can we apply the condition first? If you will apply the condition first, you will get the infinity as the effective mass value. So that is not gonna be okay. And that's why we will firstly differentiate and then we will plug in the value of k as 0. So when you're gonna find the d2e over dk square, so first time you are gonna get, when you will do the differentiation, de over dk, it will be giving you the 2a, okay, 2a a square and k, okay, plus 4b a cube a to the power 4 k cube, right? And next one is when you will do d2e over dk square, means one more time differentiation. So it will give you 2aa square, and this one will give you a 4 3 is a 12, b a to the power 4 k square. So now since you have to put k is equal to 0, so your second term will become 0 and you will just have 2aa square there. So you are going to have this as at the k is equal to 0 is equal to h² over 2a square, right? Let me know if in case there is anybody having any doubt, we can consider it then. But if everything is clear, then that's great, great, great. Done? Now, once you've got it, just plug in the value of A, capital in the small one both, and h² value as well in joule seconds. You can consider it. Okay, finally, after considering the values in the specific units, which we are gonna use here, you will be getting the effective mass value. So you can calculate it after this step. I think you are gonna get something like 19.84 times 10 to the power negative 32 approximately. Okay, and you know the mass of free electron, that is 9.1 times 10 to the power negative 31 kilogram. So you can just take the ratio of these two, and this is how you will be able to get the answer. You can also show the effective mass with the m star instead of writing the m effective. I hope it's gonna be clear, but still, if you're confused or you're gonna have doubt, just mention it. We can talk about that too. And if it is getting clear, I can give you one more question. You have to find the ratio of the m star and m. That will be your final answer. And m is the mass of free electron, as we have talked about it. Okay, so you will be getting approximately 0.22 with that. That's your right answer. The next question says, if anybody is having any doubt or difficulty in the previous part or anything we have talked about, you can surely let me know. The energy dispersion for electrons in one-dimensional lattice with lattice parameter A is options. Oh yeah, before that let's write the complete question. Given by ek is equal to E naught minus 1 over 2 W cos Ka. That's what you are gonna have, where W and E naught are constants. The effective mass of the electron give me a second. The effective mass of the electron near the bottom of the band is options are 2h square over WA square. Next one is h square over WA square. Next one is h square over 2WA square. Next one is h square over 4WA square. Try it now and let me know as you will get it done. Yep, waiting for your reply, and otherwise I will be starting the discussion too. So what is the difference in this question statement and the previous one? Previous one was saying at the bottom of the conduction band, at the bottom. And this one is saying near the bottom. So what is the difference? Near the bottom means K is just tending to 0. At the bottom means K is equal to 0. Are you getting it? So that's the difference, and this is what you have to consider. Now next thing. When you are going to consider this part, guys, what will happen next? The next thing we will be having is the EK is equal to this. Okay, we just have to find the effective mass, which is M star is equal to h square over d2e over dk square. If you are going to consider it, you will see that you are going to get the cos Ka after differentiating it twice. So when you are going to just consider the simplification, okay, what will happen? 1 minus Ka square over 2. If I'm taking that before, I'll be getting 1 minus Ka square over 2, right? So what it will give me? 2Ka square over 2. So 2 cancelled out. Then I'm just going to get a square here after differentiating. So Wa square over 2. So that's my second order derivative. 2h square over Wa square. And this is how we are going to get the answer, which is option A, which is the correct one, right? Because it was near the bottom of the bend, and when it was near the bottom of the bend, then theta, that is K, will be small because K will tend to 0, and when it is tending to 0, you can consider the cos theta having that smaller theta as 1 minus theta square over 2, and once you do that, after that you differentiate it twice with respect to K, that is second order derivative you find, then you are going to get the value. After plugging in that value here, you are going to get this answer. That's it. This is what you have to do, but still, if you're the one who is having any difficulty in solving any such type of question, you can let me know about it and we will try to consider those points too. And if it is getting clear, that's great. So let me know, guys, is everything all right and clear, or is there anything you want me to discuss? If yes, we can talk about it. If no, then that's great. So even about the effective mass tensor, I would like to tell you something. So as you are differentiating here, okay, so if it is first row first column, everything will remain same, like this part, and your denominator will be x x k x k x. First row second column, so first of all you will write first row, which means kx, and second column, which is ky. Same way here, second row first column, so second row number we write first, so h square over delta to e over delta ky and delta kx, because first column, right? And then next one will be for second row and second column, so it will be delta to e over delta ky and delta ky. So even from the tensor part, we had the questions in the previous years. How you will be working on that part, this is what you have to consider. If it is a 3 by 3 order, so again similar way you will do that. If it is 2 by 2 order, this is how you will do it, right? Let me know if in case there is still any doubt you're gonna have, we can talk about it. But if everything is getting clear, then that's great. Also guys, as in the starting of the session, I have told you about the iconic subscription or the plus subscription. So what are the benefits you will get in the respective subscription? All that has been shown here on the screen. By using and by applying the code Anjali A Live, you will be able to get the discount in the total subscription amount as well. And there are so many important courses which are going on right now on Unacademy, and there will be many courses which will be starting soon. So all the details about the Unacademy Plus, Iconic and the Lite subscription have been shown here on the screen, guys. You can have a look at that, and as per whatever you find more beneficial for you, you can take that subscription. Even you can share these details with your friends too. They will also be able to get the benefits with all these things. And whenever anybody will go ahead to take the subscription, you can use and apply the code Anjali Live as mentioned here on the screen to get the discount in the total subscription amount. Thank you so much everyone for joining the session and for